All right, this video is over limits and indeterminate form. So indeterminate form is defined by any time you get an answer to a limit that looks like 0 over 0 or infinity over infinity. Normally you would think if I'm dividing by 0, that would be a does not exist answer. But for limits, that's not necessarily true. If you get indeterminate form, it just means that you have not actually found the answer and that you need to do something else to try to figure out a way around getting your 0 over 0 or infinity over infinity. So indeterminate form is not a final answer. If you get this, then you must try something else. And the something else you could try. I'm basically going to teach you one method now, and then I'm going to teach you another method in a couple of months. That's because the other method is called L'Hopital's rule, and you need to know derivatives in order to do that. So it's going to be a while until you see that. So you might just put a pin in this for now. But the one method you can do without using L'Hopital's rule is called factor and reduce. So let's say if we have the limit as x goes to -2 of x squared minus 4 over x plus 2. So you might try direct substitution. So I'm going to take my -2 and I'm going to plug it in for all the x's. And if I did that, I would get -2 squared minus 4 in the numerator, and then -2 plus 2 in the denominator. This would be 4 minus 4 over -2 plus 2, which is 0 over 0. So this is indeterminate form. This does not mean that it's undefined. Although it is possible to get an undefined answer out of this eventually, but it's just, at least in its current state, this does not mean that it's undefined. So I'm going to do something to the original problem. I'm going all the way back to the original limit. And I'm noticing that this is a rational function and the top can be factored. So I'm going to try to factor the top and we'll see what happens. X squared minus 4, that's the difference of two squares. So that would factor to x plus 2, x minus 2. And then the denominator is x plus 2. And now that I have it factored like this, I can notice that there's a hole in the graph. If I can cancel out that x plus 2 on the top and the bottom of this rational function, that means there was a hole in the graph at x equals -2. That's why I was getting that weird answer of 0 over 0. So the function itself is not defined at that particular moment because there is a hole in the graph. However, remember a limit, you don't really care what's going on exactly at that number, even though that's what we try when we do direct substitution. The limit really wants to know what's going on close to the number, not the number itself. So by canceling out the value where the hole is, let's rewrite this limit. So direct substitution should work for us now. Now that we've gotten rid of the part that has the undefined answer, if I try direct substitution again, I just get -4 out of it.